Okay, so Monday is just a review day. We're just gonna like slow down, make sure everybody understands everything before we add tangent to the mix on Wednesday, because remember we don't have school on Tuesday. So we're gonna go over the unit circle. We'll do a practice unit circle, and we'll remember that we're supposed to know this information for the test. So these are the definitions that you have to give at the bottom of the unit circle test. Remember that that's going to be on Friday, November the 6th, as well as your parent graph test. And so we've been doing 2 a day, and so Monday will be tangent and cotangent, but I haven't been doing that in the videos with y'all. So there'll be a blank one of these for you to print and practice. And remember, if you're going to practice without printing this paper, then do it on graph paper, because it's really important that you know exactly where those points go. Make sure that you're practicing your graphs, because you're going to need to take that test. If you're not going to be here on Friday, we'll make a plan on when you can take it, because I'm not going to let you take that test at home. Okay, so after that, we're going to do a little bit of practice, just practice graphing in general, like we did on Friday, and then practice writing the equations like we did on Thursday, and then I'm going to give them a worksheet, and that worksheet is attached as your assignment. Okay, so we have to find all of the information. So to go back over how to find the info, amplitude is this number. Your period is 360 usually, and you always divide by this number right here. So if I divide by 1/3, that's really times 3, which gives me 1,080. Your increments are cutting into 4 equal sections, so divide by 4, your period by 4, and we get 270. Phase shift, you take what's in parentheses, set it equal to 0 and solve. I did that here. Add the 20, multiply by 3 to get rid of that 1/3. So you get a phase shift of 60. Your vertical displacement is this number right here, which is also your midline, just written as an equation. The max is 7, because you do your vertical displacement plus your amplitude. Your minimum is 3, and that's your vertical displacement minus your amplitude. All right, so for a graph of this, trying to see if I can fit it all on the screen. I'll try to graph it up here and try to keep my hand out of the way. We'll see if that works. All right, so here's our x-axis. So we have to label our x-axis. We start with, where did it go? Our phase shift, so 60. And then you need 4 more marks. And we're going to try to make them evenly spaced. I'm not going to count off if they're not perfect, but try to make them as evenly spaced as you can get them. All right, we're going to count by 270. So if I do 60 plus 270, I'm using my calculator, so I want to make sure that I don't get the wrong numbers and confuse you. We get 330 plus 270 is 600 plus 270 is 870 plus 270 is 1140. All right, so once you have that, as long as you have covered 1080, and we have, then you know you're right. All right, so then you place your y-axis where it needs to go. And so it's going to go real close to the 60, because that's a gap of 270. So probably somewhere around in here is where 0 would be. And again, I'm not asking for perfection. Just put it to the left of 60 a little, and you're going to be okay. All right, to label your y-axis, we use these numbers. So we have a middle point of 5, a high of 7, and a low of 3. And those are the only numbers I'm going to put on there. So we have a 3, a 5, and a 7. All right, putting a dotted line where your midline goes helps people remember that that's like my new 0. All right, so to graph, we're graphing sine. So our sine function always starts at 0, or whatever our middle number is. And then since it's a negative function, we're going to go down first. So we're going to go down to our low point, back to our middle, up to our high point, back to our middle, and draw a sine function. All right, so it has a period of 1080 because it takes 1080 degrees to make one up and down piece of our sine graph to get the whole graph. All right, so number 2. We have, I'm going to need some more paper, I can tell, so I'm going to put this there. All right, so number 2. We have an amplitude of 3. We have a period, we're in radians, we have to do 2 pi, and we're going to divide by 2. So we get pi. Then we have increments of that divided by 4, so pi over 4. We have a phase shift. We're going to take the stuff in parentheses, equal it to 0. So subtract the pi, divide by the 2. So we get negative pi over 2. We have a vertical displacement of 0. So we have a midline at y equals 0. We have a maximum at 0 plus 3 and a minimum at 0 minus 3, so negative 3. All right, so make your x-axis. Start with your phase shift. Make 4 more marks. We're adding pi over 4, so negative 1/2 plus a fourth is negative 1/4, plus a fourth is 0, plus a fourth is a fourth, plus a fourth is a half. So your y-axis goes through 0. We need positive 3 and negative 3 on the y-axis and 0 as our middle. Alright, so remember that x-axis is labeled phase shift, count by your increments. Make sure you covered a whole pi. Your y-axis is your midline and your max and your min. Alright, so we're graphing cosine. Cosine starts up high. This is positive, so it's going to start up high. So our starting point is negative pi over 2, so we start up here. And then we're at the middle, and then we're at the low, and then we're at the middle, and then we're at the high. And then we just follow our points. Remember that cosine has to curve back down. Alright, so that's graphing. So let's practice going the other way, like I give you some info and you write the equation. So even if like I gave you a graph, you could figure out this information looking at the graph, most of it. And there'll be some of that on the ACT practice for this week, so be prepared for that. Can you look at the graph and tell me the amplitude? How far is it from the middle to the top? Can you look at the graph and tell me the vertical displacement? Where did the middle of the graph move to? Can you look at the graph and tell me the period? How long does it take for you to get an entire sine graph picture? So if you have some questions when you're doing that ACT practice, it's okay to like open a new tab and Google something. Like it really is okay. All right, so we're going to have a sine function. And remember, whatever variable you use is fine. Theta, x, draw a Christmas tree. It's really fun. Whatever you want to use. All right, so we have an amplitude of 2, so that goes directly in front of the sign, and we put a plus or minus because amplitude is the absolute value of that number, so we don't know if it was positive or negative to start with. To get this number here, you take the normal period and divide by the new period, which gives us a 4. To get this number, we take what we just got, this 4, times the phase shift that they gave us, which is 720, and then change the sign when you put it in the problem. Alright, and then that vertical displacement you can just stick right in front, or if you put a minus 5 on the back, no, a plus 5 on the back, sorry, that's the same thing. Alright, so the next one, we're writing a cosine, so we say cosine of something. Alright, so again, amplitude is 4/3, but it's plus or minus because we don't know which one it is. To get this number, we take the normal period divide by the new one. So remember, we multiply by the reciprocal when we divide fractions. Pi's cancel, so this is again a 4. To get this number, we take what we just got, multiply by the phase shift, and that gives me 12 pi over 2, so 6 pi. When you write it in there, change the sign. All right, so that's just a brief recap of what we learned Thursday and Friday. There's also on this worksheet that I'm going to give you, there's some of these kind of questions. So there's a couple of you that got some of that wrong or had a question it looked like about those. So let's work a couple of those real fast, and then you can try the worksheet. All right, so if I ask you to just tell me, say, the sign at, let me think. I'm trying to make these up, so bear with me. At 405. All right, so first of all, you need to understand that to think about where that is on the unit circle or in the graph that we have graphed, we're going to subtract 360 and see that it's at 45 degrees. So this is the same thing as sine at 45 degrees. Now again, you can look it up on your graph, you can picture your graph, or you can think about the unit circle. All right, so 45 is actually not a good one when we're talking about sine, so let's change this to tangent. I didn't pick a good number because 45 is not something that we really put on our graph. So let's say we want tangent of 45. So that's really tangent of 45, and we know on our graph that that is 1. All right, for let's say cosecant of negative 180. All right, so you can picture that on your graph, like your cosecant graph. Cosecant's the reciprocal of sine, so it has asymptotes at 0, 180, 360, negative 180, negative 360. So negative 180, cosecant has an asymptote, so it's undefined. All right, so you're really just looking those up on your graphs, but by the time we take a test, you're going to need to be able to mentally do that. And the test won't be until not this week, but next week sometime. Okay, so the ones that were more difficult were the ones where if I say that sine of theta is 1, you're supposed to tell me when that happens. All right, so again, thinking about the unit circle or thinking about your graphs without looking them up, but just so that we can see what's happening, I'm going to show you on the graph. All right, so sine is 1 here and here, and it'll be 1 again over here. Okay, so it's going to keep happening over and over and over again, and it's going to keep happening every 360 degrees, because it was negative 270, the next one's at 90. That's 360 degrees apart. So we can say that theta is equal to, we know it happens at 90, that's the first positive one, and they happen 360 degrees apart. So we just say plus 360k, and anytime you put k in there as a multiplier, you have to say that k is an integer, and that's all that that little statement is saying, is k is an element of the integers. All right, so let's say that I asked you to tell me when cosecant of theta is negative 1. All right, so cosecant of theta is negative 1 at negative 90 and at 270. All right, so those are also 360 apart, and we always go with the first positive one. So when we write our theta equals, we're going to say 270 and then plus 360k. Because the first one happened at 270, and then the rest of them happened 360 away from that. All right, so one more. Let's say that I want you to tell me cotangent theta is 0. All right, so looking at your cotangent graph, cotangent is 0 at negative 270, negative 90, 90, 270. So you see that those are all happening 180 degrees apart. All right, and again, you start with the first positive occurrence, so at 90, and then tell how far apart they are. And K is just a multiplier, saying that I can add 180 a bunch of times, and I can also subtract 180 a bunch of times and get other answers that are correct. And if we say that K is an element of the integers, that is saying that we can add it whole numbers of times or we can subtract it whole numbers of times. All right, I hope that makes that better. Make sure that you do the worksheet. There's a front and a back. It's 13 questions. It's just the same stuff that we've been doing Thursday and Friday. It's just more practice. Please let me know if you have any questions.